So what we're looking at here is we're looking at similar triangles, and similar triangles are basically just where one triangle is an enlargement of the other. So you can see here that these triangles are the exact same because they have the same angles. Obviously, angles in a triangle add up to 180. So I would be able to work out this one here by saying 180 take away 42 take away 36. And I'd actually do that just to get that done. So 180 take away 42 take away 36. So let me just get 180 take away 42 take away 36 will leave me with 180 take away 32 take away 36, 42 take away 36 leaves me with 102. So that tells me that this angle inside here is 102. Okay, so this here is 102. Similarly, if I had angles in a triangle, the angles in a triangle we know add up to 180. So 180 take away 42 take away 36 will leave me with 102. So that means that angle there is going to be 102. Okay, so you can see here that you have two triangles. Obviously, this triangle is much larger than this one, so that's what we would consider to be similar triangles. Okay, just on that note, similar triangles and congruent triangles always come up side by side. Congruent means the same, whereas similar just means that one is an enlargement of the other. Okay, so we move on there and we look at question 11. Okay, and so question 11, you've got two triangles there. We've got this one here, the first one. So the first one there, which is like that, and you've got the second one there, which is like this. Okay, so in order to work out the missing sides, what I need to do is I need to map on corresponding sides. So I need to make them look the same first. So you can see there, they now look the same. Here they don't. They look, well, depending on how you view it. But if you put them side by side like this and put the same angles in the same places, then it's much easier to map corresponding sides. So I'm going to map the corresponding sides, and I'm going to keep the 10 and the 16 together, and I'm going to keep the 7 and the x together. Okay, so the way I'm going to solve this one is I'm going to just use fractions, right? So 10 over 16, 10 over 16 will be equal to 7 over x. Okay, now it's very important that if I start with this triangle, if this is my numerator over my denominator, then I have to make sure that this is my numerator over my denominator. Okay, so it's very, very important the order that we put the second fraction in. Okay, so the numerators have to be from the same triangle, right? So they have to be from the same triangle. If you've got a triangle equals a triangle, you can cross multiply. Okay, so that will give us 7x, or 10x I should say, sorry, 10x is equal to 16 times 7. So 10x will be equal to 16 multiplied by 7. And 16 multiplied by 7 gives us an answer of 112. So to find out what x is, I need to divide both sides by 10. And if I divide the left-hand side by 10, I'll get x. If I divide the right-hand side by 10, I'll get 11.2. So they asked us to find the length of x. So the answer there is 11.2 centimeters. Okay. So we'll go on there and we'll try the next one, which is question 12. So question 12, okay. In the given figure, BC is parallel to DE. So this symbol here, when we've got two lines side by side, that just means parallel. So draw the triangle ABC and ADE as separate diagrams. Mark the length of the known sides in each triangle. Explain whether triangles ABC and ADE are similar. Now find the length of DE. So we'll do it bit by bit. So they wanted us to separate these two triangles. So that's what we'll do. We'll bring that one down there. And we'll bring this one down here. Okay. Explain why these triangles are similar. And the reason why these triangles are similar is because if these lines are parallel, which they are, okay, so if these lines are parallel, it told us they were parallel, but it also showed us, so these two arrows here, that means that those two lines are parallel. So if you've got an arrow on a line, it means that the line is parallel. So those two lines are parallel. Okay. So the reason why they're both similar triangles is because if you think about it, this angle here is the same in both triangles. Okay. Also, this angle here, okay, is going to be equal to this angle here because they're what we call corresponding angles. Okay. Because this here is basically just sliding. So let's just look. So this here, if it's corresponding, it slides down. So it's actually worth the same value, right? So that triangle is actually sliding down there. So that angle there is going to be the same. So I'm just going to indicate that that's the same. And the reason why it's the same is because it's corresponding. Okay. And the last angle there is also corresponding. So this angle here is also the same. Okay. So when it asks you to show why the two triangles are similar, I'll just write down why they're similar. And the reason why they're similar is because you've got three angles the same. So what I expect you to try is triangle ABC and triangle ADE similar three equal angles. Now, again, it's important. If triangles are similar, it just means that they have the same angles. If we were looking at congruency, which is very similar to looking at similarity, congruency means that they're the same. We know these triangles aren't the same because obviously this one is much larger than. So this is 4, this is 7. So we know they're not congruent because if they were congruent, they would be the same. Okay, so they're not the same, they're similar. Now find DE. Okay, so they want us to find the length of DE. So let's just look at what we have. We have the length of side AB, which is 4, and that maps onto the length of this side AD, which is 7. So I'm going to put that in there. Because 4 plus 3 gives us 7. So 4 plus 3 gives us 7. So the length of AB is 4, the length of AD is 7. They want us to find this length here. So I need to map on my sides. So the two sides that I'm going to map together are going to be, I have 8, and I'm looking for this side here. Okay, so I'm looking for this side here. So I'm going to call that X. Okay, so in order to map my sides together, I need to form fractions. So I'm going to say the first one there, which is 4 all over 7, will be equal to the first one, which is 8 all over X. So 4 over 7 is equal to 8 over X. Okay, so I've formed an equation there. I've taken the first one, which is 4, put it over 7, taken the first one there, which is 8, put it over X. I've formed an equation there, and in order to solve that equation, I'll need to cross multiply. So 4 times X is 4X. 8 times 7, 8 multiplied by 7 gives us 50. 6. I'll actually just write that out. So 8 times 7, just for anyone that's unsure. So that'll give me 4x is equal to 56. In order to find out what 1x is, I need to divide both sides by 4. So if I divide both sides by 4, 4x divided by 4 will leave me with x. 56 divided by 4 will leave me with 14. So my answer there for DE is equal to 14. With question 13, right? So ABCD is a quadrilateral in which the length of AB is parallel to the length of DC. So the length of AB is parallel to the length of DC. So those two sides are parallel, as all they're saying. Okay, and we know that because it's given with arrows. And the angle DAB, D to A to B, it's the blue one there, is equal to the angle C to B to D. So C to B to D. So you can see those angles are equal. Okay. Name two other equal angles in this figure, right? So we can see there the two dots. So that represents those two angles are equal. And we should know why they're equal. And the reason why they're equal is because they're alternate. So this angle here and this angle here are what we call alternate angles. So they're both equal. So the two angles that are equal are the angle, okay, I'll just put that down there. The length of the angle, let's say ABD, is equal to the length of the angle CDB. Okay. So let's just look at that and see what way that is, right? So if we take the first triangle, we bring that down. And we'll take the second triangle and we'll bring that down. Okay. You should be able to see that these are similar enough. What I'm going to have to do is I'm going to have to flip this and I'm going to have to bring it down. So you can see there how those two triangles are going to be similar, because this angle here will be equal to this angle here. This angle here will be equal to this angle here. So obviously this angle here will be equal to this angle here. And the reason why I'm saying obviously is because angles in a triangle add up to 180 degrees. Okay. Now, part 2 of that question says, now explain why triangles ABC and DCB are similar. And we've just explained that there because all the angles are equal. Okay, so all the angles are equal. For part 3, which side of DCB corresponds to DB? So if we're looking at DB, so DB is from here to here. So which side corresponds to that? And the side that corresponds to that is going to be this one here, which is AB. Should be a V there, so I'll just put the V in. Okay. So the answer there, which side corresponds to DB? The side that corresponds to DB is AB. Which side in ABD, so ABD, so which side in this triangle corresponds to BC? So which one corresponds to BC? So BC is here. So the corresponding side in the corresponding triangle is going to be this side, obviously. So DA, isn't it? If DC was equal to 15, so we can see that there. Obviously, I flipped the triangle, so everything is backwards. But if DC is equal to 15, so if this side here is equal to 15, and this side here is equal to 12, find AB. So the unknown side that I'm looking for is down here, isn't it? Okay. So I need to pick the corresponding sides that have numbers. So the ones that have numbers are the ones I'm going to use first. So the ones that have numbers are going to be this side and this side, which correspond. And I'm going to see how they map onto this side and this side. Okay. So I'm going to form an equation, and I'm going to start off by using the fractions there, right? So with my fractions, I will do the first one there, right? So 12 over 15, 12 over 15 will be equal to x over 12. And it's very, very important that we make sure we're getting this right. So we do 12 over 15. So we're taking the numerator from the first one over the denominator of the second one is equal to the numerator over the first one over the denominator of the second one. So now we've formed an equation. And the reason why we know it's an equation, obviously we've got an equal sign. So we need to solve that equation. And how we solve that equation is we cross multiply. So cross multiply. So we'll say 15 times x is 15x. And 15x will be equal to 12 times 12. Okay. So 15x will be equal to 144. So to find out what x is, I need to divide both sides by 15. So 144 divided by 15 gives us 9.6. And that's obviously in centimeters. So just to quickly go through what we did there, we mapped the corresponding sides together. So 12 over 15 is equal to x over 12, x over 12. Then we cross multiplied. So we said 15 times x is 15x, 12 times 12 is 12 times 12, 15x is 15x, 12 times 12 is 144. To get 1x by itself, we divided both sides by 15. So 15x divided by 15 leaves us with x. 144 divided by 15 leaves us with 9.6. Okay, so that's the length of AB. So the answer there is 9.6. So what we had here, we had two triangles. You can see there that we have alternate angles. So those two blue ones are equal because they're alternate. Similarly, these two red ones here are alternate. So those two red ones are alternate. So you can see there that obviously we've got vertically opposite angles here. So if we bring that shape down here and this shape down here, okay, or I should say the other way around, if this comes down here and if the small one comes down here. So we were looking for the value of x. So in order to find the value of x, we used two sides that we knew, which were the two blue ones, and 12 over 18 was equal to the red ones, which is 9 over x, okay? And then we cross multiplied, we got that. And then to find the value for y, we divided both sides by 12, okay? Similarly, when we're looking for a value for y, we took the two sides that we knew, and we said 12 over 18 is equal to, and then we took the two y values. So we said because 12 came from this fraction, we had to make sure the numerator came from this fraction, or from this triangle too. So that was 18, so we put 18 in, and obviously y was in the first triangle. And then we cross multiplied. If we cross multiplied there, which we did, we got 12y is equal to 18 by 18. So that will give us 12y is equal to 324. So to find out what 1y is, we divide both sides by 12. Now, the important thing for you to note at this stage is you can see here, what I did with this here was I took 12 and put it over 18. I would get the exact same answer if I had taken 18 and put it over 12, right?